continuing on. Okay, this one is not in y equals mx plus b form. It's not in slope-intercept form. So the first thing I want to do is rewrite to slope-intercept, or that's y equals mx plus b. So the first thing I'm going to do is move that 3x to the other side. And then I'm going to divide all the terms by 4. So 4y divided by 4, negative 3x divided by 4, 12 divided by 4, to give me y equals negative 3/4 x plus 3. Then once I have it in that form, easy enough, my slope is negative 3/4. And my y-intercept, you can't really read that, can you? I have horrible handwriting. My y-intercept is 3. Okay, last one of this nature, and there's nothing special about this one, but every once in a while they're just going to throw function notation there. I remember way back when I was a girl, back when I was taking my first algebra class back in 8th grade, I was wildly confused at first by that f of x, until I realized that most of the time, all I had to do if I saw an f of x that was bothering me, replace it with a y. And so there are a few problems where they suddenly use function notation instead of y equals. You can always replace the f of x with a y. And once I do that, my slope would be negative 5/7. My y-intercept 8, or if you prefer, 0.8. And I did not write that up on this one, 0.3. Remember, when we're talking about intercepts, the other coordinate is always 0. Since we're talking about y-intercepts, the x coordinate is going to be 0. Okay, doing some more here. Same instructions, find the slope and y-intercept. Now this one I could rewrite to slope-intercept. Whenever my instructions really pretty much are find the slope and intercept, you're going to want to rewrite to mx plus b, and then use our facts that we know about that the slope is m, the y-intercept is b. So I can do that. I'll take the 18 to the other side. It becomes negative. I'm going to divide both sides by 3. And so I get y equals 6, which I could do this if I wanted to. 0x plus 6. Just being really, really, really specific that it's 0x plus 6. And once I do that, my slope is m equals 0. Now, if I had actual students in this classroom, instead of just talking to an empty classroom, I would ask the class, what's that tell me about the line? What did we just talk about, 10 minutes ago about slopes being 0? Well, one of the things we talked about just a little while ago, right here, that when a slope is 0, the line is horizontal. So we know that this is a horizontal line. So horizontal. Even though it didn't ask us for that information, we'll throw it in there because I'm going to use that information momentarily. And then we can also see that the y-intercept is 6. Or 0.6. Now the reason why I threw that information here, and we'll pop down to the minute, bottom here, fact. Y equal a number. And that's what we ended up with here. After we're doing our business of solving for y, we end up with y equal a number. Fact. Y equal number is a horizontal line with a slope of 0 and a y-intercept of that number. So anytime you just see y equals a number, instead of going through this rigmarole of what is the answer, rewrite it all, y equal number, you automatically know it's going to be a horizontal line, which means the slope is 0, and the y-intercept is just going to be that number. Okay, when we look at the next one, there isn't a y. There's no y, so let's solve for x. And so I'd get 2x equals 4. Divide both sides by 2, x equals 2. And then again, if there was a classroom of people here, I would say, well, if y equal a number was a horizontal line, what must x equal a number be? And usually this question goes, people know the answer that if y equal a number was horizontal, x equal a number must be vertical. And that's what we have down there. That x equal a number is a vertical line with an undefined slope and no y-intercept. So your life will be a little bit easier if you just memorize these two little facts. Y equals number is a horizontal line with a slope of 0 and a y-intercept of that number. X equal number is a vertical line with undefined slope and no y-intercept. Now there's one caveat here that I do throw in there, trying to be a perfect teacher, which is kind of a stupid thing. No one can be perfect. But if I'm attempting to be a perfect teacher, I would then tell you that there's no y-intercept except in the case of x equals 0. The line x equals 0 is the equation of the y-axis. It's the y-axis itself. And if you're talking about the y-axis, then every single point is a y-intercept. So when you're talking about the equation of the y-axis, which is x equals 0, yes, the slope is undefined, but it actually has infinitely many y-intercepts. Now, I'm not going to put on a test I'm not going to try to trick you up. For all other vertical lines except the y-axis, the slope is undefined and there's no y-intercept. So once I know that, I now have x equal a number. So we automatically know that the slope is undefined. And the y-intercept, there isn't one, none. Now don't write 0, because 0, it would indicate there is a y-intercept. The y-intercept, there is none. And also on the slope, please do not write the word none. The only things you're ever going to write for slope are a number or the word undefined. Those are the only acceptable answers for slope. Okay, we're going to continue talking about slope. Slope as rise over run. So I went back to my graph that we had a t-chart before, y equal 2x plus y equal 2/5 x plus 1, and we know that m equals 2/5, and it has a graph like that. Then I've just drawn the graph again, connecting those points on my t-chart. That point, if we go back, and you remember the t-chart that I had for this, way back here, there was my t-chart, and this point down here was -5, -1. That point there from my t-chart, 0, 1, and that last point there, 5, 3. So all I've done is I've purposely drawn in my points really big so we can see them, and then I drew triangles in there. Now this isn't to scale. I didn't want to play around with my computer enough to make it to scale. And what I mean by that, notice the x-axis is measured differently than the y-axis. So it's not to scale. But that being said, if I look at this the horizontal distance each time, and I count how many spaces we went over from here to here, we went from -5 to 5. And so let's do this in green. That's a distance of 5 units. And the same thing here, from here to here, this horizontal distance, that's a distance of 5 units. Horizontal distance is called the run. And in this case, it was 5 units. Okay, let's pick a different color. Yellow. So yellow right there. That vertical distance. And just counting the spaces we go up. So we go 1 space, 2 space. It's 2 spaces. Or it goes from 1 to 3, 3 minus 1, 2 spaces. So 2 units. And the same thing here. If I do this yellow line right there, the spaces I go up. I go from -1 to 0, 0 to 1. The number of spaces I go up, the distance, 2 units. The vertical distance we call the rise. And in this case, it's 2. Then notice if we do rise over run, we get 2/5, which we know is our slope. So there is another way to think of slope as rise over run. And that's everything that we have down there, rise over run, everything that's written down there. Another way we can think about slope is rise over run. And again, notice I was counting each one of these distances in a positive direction. I counted from left to right, positive direction, from down to up, positive direction. So these distances were measured in a positive direction, so +2 or +5 slope. Now the nice thing, or rise over run, slope. The nice thing about rise over run is it's going to give us a very easy way to graph lines. And so that's what we have down here. Graphing using slope-intercept and rise over run. And this is the way I'm going to graph all my lines. Now you are welcome to graph any way you want. If you like to make a table of values, make a table of values. If you had a high school teacher that taught you to graph using intercepts, you can use intercepts. This is just my particular way I like to graph. 1, if necessary, rewrite the equation in slope-intercept form. 2, identify the y-intercept and plot it on the y-axis. 3, identify the slope as a fraction, then counting from the y-intercept, count off the units as rise over run and plot a new point. If the slope is positive, count up and right. If the slope is negative, count down and right. If we always go right and just let positive be up and right and negative be down and right, it solves making silly mistakes. So that's what we're going to do. Then 4, connect the 2 plotted points with a straight line. There's graphing using slope-intercept. So let's practice some problems. Okay, first thing we want to do is write in slope-intercept form. So 7y equals -3x plus 14. Divide everybody by 7. And so we get y equals -3/7x plus 2. So then my y-intercept will be 2. My slope is -3/7, and we are going to view that as down 3, right 7. So then graphing that, y-intercept 2, 1, 2. And I think I'll graph in green. So there's my y-intercept. Then counting from my y-intercept, I count off the slope. Down 3. 1, 2, 3. Right 7. 1, 2, 3, 4, 5, 6, 7. And I'll just draw my tick marks along here too. So down 3. Right 7. Plot a new point. Connect the dots. And that guy is graphed. And that's the way I like to graph. And I hope that you like it too. Come test time, I'm not looking for all the color. I'm just looking for the tick marks and the line. And that's where we'll end this video.